Hello everyone. Today we will solve a very interesting question. This question is asked in IIT JAM Mathematics 2020. Okay. This question is from real analysis. Let us study the question. Here the sequence Sn is defined in this way: Sn equal to 1 plus minus 1 whole to the power n f on n. Okay. We have to check the whether the sequence is monotonically increasing, monotonically decreasing, and its limiting value, its convergence to 1 or not. Okay. First of all, let us compute S1. S1 equal to 1 plus minus 1 whole to the power 1 divided by 1. It gives 1 minus 1, which is equal to 0. Okay. S2 equal to 1 plus minus 1 whole to the power 2 divided by 2, which gives 1 plus 1 by 2, which is equal to 3 by 2. Okay. Similarly, S3 equal to 1 plus minus 1 whole to the power cube divided by 3, which gives 1 minus 1 by 3, which is equal to 2 by 3. Okay. If we will arrange these three terms in sequence, then we will get S1 less than S2, which is greater than S3. If we will observe this pattern, then initially it was increasing, but from S2 to S3 it is decreasing. So the sequence is neither increasing or nor decreasing. Okay. So option 1, monotonically increasing, is not true, because it is also from S2 to S3 it is decreasing, and monotonically decreasing also false, because initially it was increasing S1 to S2. In option C it is given that it is neither monotonically increasing nor monotonically decreasing. It is looking like nearly true, because we have to check its whether it is convergent to 1 or not. Let us check it. The given sequence is Sn equal to 1 plus minus 1 whole to the power n divided by n. If we will break this sequence into two subsequence, we will mainly consider even sequence and odd sequence. We will mainly consider two subsequence. So one is even subsequence, another is the odd subsequence. Okay. Even subsequence takes the form s to 2n equal to 1 plus minus 1 whole to the power 2n divided by 2n, which is equal to 1 plus minus 1 whole square whole to the power n divided by 2n, which gives 1 plus 1 by 2n. It tends to 1 when n tends to infinity, because this term goes to 0 when n tends to this term goes to 0 when n tends to infinity. Okay. Similarly, if we will calculate S2n plus 1, the odd subsequence, then 1, it gives 1 minus 1 whole to the power 2n plus 1 divided by 2n plus 1. It gives this quantity is an odd quantity, and minus 1 to the power odd number gives minus 1. Okay. It gives 1 minus 1 by 2n plus 1. It gives 1 minus what 2n plus 1. Okay. It also goes to 1 when n tends to infinity, because this quantity also goes to 0 when n tends to infinity. Okay. So we get that S2n converges to 1 n tends to infinity. S2n plus 1 also goes to 1 when n tends to infinity. And we know that if the odd subsequence of a sequence goes to, if the odd subsequence goes to L when n tends to infinity, and the odd subsequence and the even subsequence goes to L, the limit point L, and when n tends to infinity, then we say that then these things imply that Sn tends to L, then the sequence converges to L. This is a nice result in the real analysis. Means when the odd subsequence goes to the same, when odd subsequence and even subsequence both convergent and they converges to the same limit L, then the sequence itself is a convergent sequence and it converges to L. Okay, so from this result we conclude that limit n tends to infinity Sn equal to 1 in our problem. Okay, so our Sn is a convergent sequence and it converges to 1. So the answer C is true. It is neither monotonical decreasing nor monotonical decreasing and it converges to 1, and it is not a divergent sequence, so option D is false. Okay, I hope you all understand it. Thank you all. Bye bye.